Okay, in this video we're going to take a look at the derivative of logs. So let's go ahead and begin. Learning goal. Students will be able to take the derivative of logs. So by the end of this video you should be able to take the derivative of logs. Remember that we are going to be using probably some chain rule. What that means is this. If I take the derivative of a function within a function, I'm taking the derivative of the outside times the derivative of the inside. Okay, let's see what other formulas we have. So differentiation rules. If I have log of base a of x and I'm taking the derivative, that's simply 1 over ln of a times x times the whole quantity x prime. Now notice that this formula does work and it's very similar to a to the x. So the derivative of a to the x we saw in an earlier video was basically this. The derivative of a to the x was equal to ln of a times a to the x. So please don't get these two confused. They're not the same. Yes, a to the x and log base a to the x are definitely inverses of each other, but the derivatives are different. And then here we have basically the same idea, but in terms of u instead of x. So let's see how we can actually do this. Now, I apologize. This should be actually bumped up here. The wacky PDF sometimes does some interesting stuff. So let me go ahead and color code it for you guys. Let me do the first one, part A, in red. Okay, so I'm just going to use the formula here. If I take the derivative, I get y prime is equal to 1 over ln of 3 times x, and then the derivative of x is just 1. So you end up getting, in this case, 1 over ln of 3 times x. Done. That's how easy it is. Okay, let me do part B in blue. Same game, and part B says here log of base 10 of 2x. Okay, so no chain rule needed, but a little bit of taking the derivative. So y prime is equal to 1, over ln of, in this case, 10, the base, times 2x, and then times the whole quantity by the first derivative of 2x, which is 2. And so you end up getting 2 over ln of base 10, ln of 10 times 2x. Alright, not too bad, huh? It's all about the formula in this case. Alright, so let me write down the formula again. It says basically this. Log of base a of x, if I take the derivative of it, that just gives you 1 over ln of a times x times the whole quantity by the derivative. Okay, so let's go ahead and give it a go. F prime of t is equal to 1 over ln of 10 times cosine t, and then the derivative of cosine t is going to be negative sine t. So there it is in all its beauty. Okay, so the next one looks like it might be chain rule. Let me switch colors to switch gears a little bit. Let me rewrite this. This can be the same as log of base 5 of t squared minus 1 all to the 1/2 power. Now we can drop down the exponent properties of logarithms, so we don't have to do chain rule. I'm going to leave it as chain rule so we get some practice. Okay, so the formula, let me scroll back up, is right there. So this is equal to f prime of t, which is going to be in this case 1 over ln of 5, and then times basically t squared minus 1 to the 1/2 power. Now on the top I'm going to take the derivative, so times, okay, it's chain rule, so the derivative of the whole thing is 1/2 t squared minus 1 to the negative 1/2 power. Derivative of the inside is just 2t. Done. Not too shabby. It's not very pretty, but we're done. On the next one, we're going to actually use a property of logarithms because I don't want to do quotient rule here. So let me first rewrite this. Let me say that this is log base 10 of x squared minus 1 minus log base 10 of x. So I can do that. That's just one of the properties for logs. Okay, so now let's take the derivative. So the formula once again is, let me write it in blue, log of base a of x. If I take the derivative, that's just equal to 1 over ln of a times x times the whole quantity x prime. Okay, let's give it a go. The first one looks like this. Y prime is equal to 1 over ln of 10 times x squared minus 1. And then if I take the derivative of the x squared minus 1, I just get 2x. And then minus, let's take the derivative of the next one. Okay, that's just going to be 1 over ln of 10. Wacky parentheses everywhere. It's okay. And then times x, and the first derivative of x is just 1. And there you go. It's not so pretty, but it's pretty easy actually. Okay, let's do a couple more. Alright, part B. Let's see if we can do it without the formula this time. Y prime is equal to 1 over ln of 10 times 2x and then times 2. Alright, not too bad. Once again on this one, let's go ahead. It's the last one. Let's do some rewriting before we take the derivative. It might make it a little easier for us. So log of base 2 of x squared minus log of base 2 of x minus 1. Okay, let's apply the formula. F prime of t is equal to, in this case, 1 over ln of 2 times x squared, all times the first derivative, which is 2x, minus 1 over ln of 2, and then in this case I've got x minus 1, take the derivative, that's just 1, and there it is. Okay, so let's scroll back up to, before we look at the learning objective, let's look at the actual formulas. This is a must-needed formula. You got to know it. Very easy to apply, and please don't get it mixed up with a to the x's derivative. In terms of the learning goal, students will be able to take the derivative of logs. I truly believe you're going to be able to do this. I know you didn't like logs in Algebra 1 and Algebra 2, but in calculus it's fairly easy. I'll see you in the next video.